You start.
Okay. Hello. Thank you for having us. I'm Bryce Goodman. This is Beam Kim, and we are here today to announce the Explainable Machine Learning Challenge. So, the Explainable Machine Learning Challenge is being sponsored by FICO, and some of you may not know who FICO is. So FICO is the largest credit rating agency in the world. The FICO score was introduced in 1989, and it provides a credit score to lenders based on consumer credit files. So 90% of all financial lending decisions in the US make use of this FICO score. And the challenge that we're running is going to look at the FICO score for the home equity line of credit. So this is a score that in this case is being used to decide whether or not somebody gets given a loan on their house. So these are the components of the FICO score. So you can see it's made up from credit information that they get from various bureaus like Experian, etc. And it has components like the payment history, their credit mix, length of credit history, etc. The FICO score ranges down to 300 and then goes up to 800, which indicates a high score and good creditworthiness. So the motivation for FICO doing this challenge is really to move their prediction paradigm. So right now, FICO is largely relying on a handcrafted additive model to do their FICO score generation. And they'd like to move towards more powerful modeling techniques. But on the other hand, the lenders that they work with all utilize reason codes that provide localized explanations. So an example would be something like, you have too many lines of credit open, and that's why you weren't allowed to have this loan approved. But those explanations are localized and also quite brittle. So another motivation for FICO is to just generally improve the quality of explanations that their lenders are able to give. So some additional motivations for interpretability in particular. So one is a sense check. So the FICO model, sometimes the data that gets fed into a FICO model is frankly bad data. So they may have entered in something incorrectly, there could be missing fields. And so the FICO analysts, before switching to any kind of a black box model, want to have the ability to make sure that the predictions are being made utilizing sound data. So that's that sort of sense check function is one motivation for interpretability. Another is fairness. So they are interested in making sure that their lending policies and banks are interested in making sure their lending policies are compliant with all the federal regulations around bias, making sure that there's not racial discrimination or age discrimination or other forms of malicious discrimination. Another is compliance. So in this case, we're referring specifically to requirements around explanations. So the European GDPR has a concept of a right to explanation, and this kind of casts even more light on this general need for explainability, particularly when you're dealing with decisions that have such a massive impact on people's lives. And then iteration is another reason. So the ability to understand how the model is performing and also how it might be improved by new sources of data. So here it's less from a compliance or an outward-facing point of view, but more from an internal data science point of view, wanting to be able to interrogate the model and see how it might be improved. And the bottom line that I'd say here is that machine learning simply won't move into regulated sectors like finance without some level of interpretability. And I'm really excited to see the debate that's happening later tonight. But I would also caveat that regardless of the opinions of the people in this room, the finance sector as a whole, when it comes to decisions around consumer lending, which are highly regulated, they simply can't make use of models if they can't have some level of interpretability. So why should you be excited? So the FICO predictions literally change the course of people's lives. As I said, these are being used in 90% of all financial lending decisions in the world. So every time somebody wants to get a loan for a house or a credit card, that FICO score is probably a key component of that. And then the second is that the data set that FICO is making public has never been released before. And we think that's a really exciting opportunity for researchers that want to look at a data set that's specifically being designed with explainability in mind. And then finally, this is really an opportunity to move interpretable machine learning from theory into practice. So, FICO is putting a lot of weight behind this, and it's basically said that they want to move towards a machine learning-based approach for their predictions, but without interpretability in place, they simply aren't going to do that. And I think that really speaks volumes to how critical the work that everybody's doing on interpretability is, but also speaks to the gap that still exists between the theoretical dimensions of interpretability and how that's being deployed in the real world.
Hi, my name is Ian Kim. I'm from Google Brain. I'll continue this conversation around the challenge. So then the natural question that you might ask is, so how are you going to evaluate this? Who are we generating the explanations for? Before we talk about that, we need to first have a conversation about the different types of interpretability methods. First type is method that you can do before even building the model. So exploratory data analysis, getting descriptive statistics out, all falls into this type of interpretability method. Second, you can build a brand new model where interpretability is inherently embedded into your model. But not everyone has this luxury of building a brand new model from scratch. So then often in industry, we ended up with a already trained model that many engineers' effort gone into in years. So these are three types of interpretability method. So we are going to break down our challenge into pieces so that each piece will focus on one or two of these interpretability methods. I said maybe because we're going to do the first one and we'll see how it goes. But if we're going to commit second and third, it's like a multi-year commitment, so we're not quite ready yet. So we're going to do the first one and do it well and see where that takes us and how we can move field forward using this type of challenge. So first round is going to be a target audience for machine learning engineers, perhaps at FICO or a similar job. What we are going to provide you are data set and the target variable, and you're going to build machine learning interpretability methods that is for building before a machine learning model, and we're also going to ask you to build a model that is inherently interpretable. Then we're going to evaluate those explanations based on tasks that mirrors data analysis at FICO or a similar job. Second round, we will look at explanation methods for regulators. The goal of regulators, they want to make sure that these machine learning systems are not violating laws, such as discriminations. So in addition to data and target variable, we're going to give you a set of trained models that perhaps has intentionally flaws that we intentionally inserted. And third, I think it's relevant and interesting to look at interpretability methods for customers to not only gain their trust, but also make sure that we expose some truths to the model while not allowing them to game the system. So in academia, including a lot of work in my work as well, we often do second and third level of evaluation in this chart. Human grounded or functionally grounded. Functionally grounded basically just means that you have some proxy for what is interpretable for humans, such as sparsity. So if your function gives you 10 out of 100 features and not 5 out of 100 features, then that is better interpretable than other methods. In this challenge, we have a unique opportunity to work side by side with application and task users, and they are with the real humans with the real tasks, so that as we develop these methods, we can develop something that will be ultimately useful for and task users. So obviously, we don't have all the details right now for you, but we're excited that this is an opportunity not only for moving field forward, but also change the way that interpretability methods are implemented, used, and understood in the industry. So if you're interested in being posted, please send an email here, or there's also a link in the website, the symposium website, where you can sign up. Thank you.